Hello everyone, this is Revathi working as an assistant professor in the Department of Information Technology from SNS College of Engineering, Coimbatore. In my previous video, we have seen about user datagram protocol, that means UDP, and the transmission control protocol, that means TCP. In this lecture series, we are going to see about TCP flow control, how the flow is controlled by using transmission control protocol. Let me see, let me move on to the topic. Here is the control balances and rate. A center creates data with the rate a receiver can use the data. This architecture will explain about how the data and flow control will be done by the DCP. Here, the center is act as a producer, then the receiver is act as a consumer. The producer produces data and the consumer consumes the data which is coming from the producer. Here the producer is nothing but application layer, the consumer is nothing but the transport layer. Then again the producer is in the transport layer, then the another receiver side transport layer is the consumer, and top of the transport layer is the producer, and the receiver side application layer is act as a consumer. Here the producer produces items to the consumer, then it will segments are pushed to the receiver, and it will receive the items, and also it will pull the messages to the application layer. This is the whole process of data transmission, which is in the transmission control protocol. Actually the transmission control protocol is in the transport layer. Then another one important mechanism here is opening and closing windows. To achieve flow control, TCP forces the sender and receiver to adjust their window sizes. The receiver window closes when more bytes arrive from the sender. It opens when more bytes are pulled by the process. The opening, closing, and shrinking of the send window is controlled by the receiver. The send window closes when a new acknowledgement allows it. When the send window opens when the receive window advised by the receiver allows it to do so. Then this diagram will explain about how the windows is opened and how the windows is closed after the transmission. Then next mechanism is shrinking of windows. The receive window cannot shrink. The send window, on the other hand, can shrink if the receiver defines a value for rewind that results in shrinking the window. However, some implementation do not allow shrinking of the send window. The limitation does not allow the right wall of the send window to move to the left. The receiver need to keep the following relationship between the last and new acknowledgement and the last and new rewind values to prevent shrinking of the send window. Here the new acknowledgement number plus new rewind number is greater than or equal to last acknowledgement number plus last rewind number. The relationship shows that the right wall should not move to the left. This is for shrink explained for shrinking of windows. The window after the new advertisement window can shrink. Next one, important concept in TCP is silly window syndrome. A serious problem can arise in the sliding or window operation when either the sending application program creates a slowly or the receiving application programs consumes data slowly, or both the sides. These situations results in the sending of data in very small segments, which reduces the efficiency of the operation. It degrades the TCP performance and make the data transmission extremely inefficient. There are two main causes of this syndrome as follows: center window transmitting one byte of data repeatedly, then receiver window accepting one byte of data repeatedly. Then syndrome created by the center. The sending TCP may create a silly window syndrome if it is serving an application program that creates data slowly, for example, one byte at a time. Here, the Nagel's algorithm is used for silly window syndrome concept. Here, the sending TCP sends the first piece of data it receives from the sending application programs, even if it is only one byte. After sending the first segment, the sending TCP accumulates data in the output buffer and waits until either receiving TCP sends an acknowledgement or until enough data have accumulated to fill a maximum size segment. This is the second step of this algorithm. At this time, the sending TCP can send the segment. Then the step 2 is repeated for the rest of transmission. Segment 3 is sent immediately if an acknowledgement is received for segment 2 or if enough data have accumulated to fill a maximum size of segments. Then another one is syndrome created by the receiver. The receiving TCP may create a silly window syndrome if it is serving an application program that consumes data slowly, for example, one byte at a time. Here, the Clark's solution is used, sending an acknowledgement as soon as the data arrive, but to announce a window size or 0 until either there is no space to accommodate a segment of maximum size or until at least half of the received buffer is empty. Thank you.